Hello and welcome. My name is Susan Obajeski, and I will be your instructor for this course material. The course is entitled The Citizen Data Scientist Journey, and the material is meant to provide a solid foundation for your business, and more importantly, for those members of your team you may be considering as early adopters or champions of the Citizen Data Scientist transformation within your organization. So let's get started. Let's start with the definition. Gartner defines a citizen data scientist as a person who creates or generates models that leverage predictive or prescriptive analytics, but whose primary job function is outside the field of statistics and analytics. The target audience for this course includes members of the business community that are by their nature ideal candidates for the citizen data scientist role. Specifically, business users with a primary job function outside of data science or analytics. Also, IT professionals who are interested in data science and team members who share data, analytics, and insight with other business users to advance goals and objectives. The content of this course is comprised of material from a one-day workshop offered by the Smarten Augmented Analytics team, and designed to help business users and organizations initiate data democratization, data literacy, and citizen data scientist environments within an enterprise. This course will educate, illustrate, and excite your business and your team, and explain the concept of a citizen data scientist, the benefits of such a program, and the analytical roles and processes that will serve as a roadmap to define roles and responsibilities. We will also look at the analytical techniques and algorithms business users can leverage and how this will help users achieve fact-based decisions. We'll examine predictive analytics use cases to illustrate how these analytical techniques can be used to address business issues and identify opportunities. And we will see assisted predictive modeling in action through a demonstration of the Smarten tool. It is important to note that this course material is by no means a comprehensive training session meant to produce expert citizen data scientists. The journey to data democratization and citizen data scientists will, by necessity, include significant cultural changes and processes meant to encourage the adoption of augmented analytical tools and a focus on data-driven decision-making. By the end of this course, participants will understand the role and value of citizen data scientists and the benefits to the organization, as well as the integration points and cultural shifts that will position analytical professionals and citizen data scientists to work more productively. Participants will gain a basic understanding of applicable analytical techniques, including predictive analytics, and how to apply these techniques to real-world business use cases, and the augmented analytics tools they can use to make fact-based decisions and move the organization forward. Now, if you are ready to start your journey to the citizen data scientist community, let's begin. First, let's get a common understanding of the ideal candidate for citizen data scientist. Citizen data scientists are not business analysts or data scientists. They are business users and team members within the organization. The typical profile of an ideal citizen data scientist is a person who is respected within the organization and often shares data and information with other users to collaborate and produce outcomes that are designed to achieve goals and objectives and a successful result. These individuals may already be power users of business applications and may have developed and reported or presented data to others with an eye toward clarifying their decision-making. Citizen data scientist candidates may also be IT team members who are interested in data science. In any case, these candidates will typically be uniquely curious, interested in data analytics, and devoted to fact-based decisions and team collaboration. Take special note of the final two bullets on this page, as they reflect characteristics and traits that will help you identify the perfect candidate, no matter what their current role in the organization may be. Whether you are taking this course to better understand how your business can leverage the citizen data scientist concept and identify potential candidates, or you are one of those candidates, it is important to understand the role of a citizen data scientist in business, as that is what will ultimately define your success and how, when, and where data and analytics will be used to improve productivity and results. Take a moment now to read through the examples on this slide and notice that the role of citizen data scientist is to use augmented analytics. That is, analytics that provide simple recommendations and suggestions to help users easily choose visualization and predictive analytics techniques from within the analytical tool, without the need for expert analytical skills. When a citizen data scientist uses these tools, the resulting analysis can be combined with professional knowledge and specific domain skills of the individual to better understand and gain insight into trends, patterns, issues, and opportunities, and improve time to market, accuracy of predictions, and metrics and measurements. Adopting these tools and techniques and actively engaging in augmented analytics allows the citizen data scientist to more effectively interact with and collaborate with the IT team and data scientists to prepare data and use data in use cases and to refine outcomes and improve data-driven decision-making across the enterprise. If you are still trying to identify the right candidate, or if you are a candidate trying to decide whether you are the right choice, this information might help you. We've already talked about the fact that your citizen data scientist role is usually adopted by someone who is already a respected member of the team. But this profile will broaden the perspective somewhat. Here, we look at the characteristics of the team member and add some context to include the fact that the team member may also need external data to do their job and make good decisions, and may already be using tools like Excel as a power user. By identifying and nominating team members with these characteristics and needs, your business will increase the likelihood that the candidate will see the value to them and to the organization and be more likely to adopt and settle into the citizen data scientist role. Take a moment to read through this list and see if anyone comes to mind in your organization, or if you as the candidate can see yourself in this profile. Your business is not likely to adopt any new initiative or program without a demonstrable benefit. Fortunately, when it comes to the concept of citizen data scientists, the benefits are significant, and those benefits will reap rewards across the enterprise, with productivity gains, undeniable improvement in team member empowerment and accountability, and many other benefits. By transforming business users into citizen data scientists, the organization will enjoy support for data-driven, fact-based decision-making, and will gain insight and perspective and clarity. The citizen data scientist community will develop a synergy with data scientists and business analysts by sharing data and speaking the same analytical language. The enterprise will improve business agility and efficiency, and decisions will be made in a more timely and accurate manner. In this section, we will look first at the benefits to the citizen data scientists, then to the benefits to data scientists, and finally, the benefits for the entire organization. Citizen data scientists can bridge the gap of data science skills by gaining knowledge and skill in the use of augmented analytics solutions that provide sophisticated tools with easy-to-use auto-recommendation and guidance so users can gather, create, and analyze to produce clear results and find solutions and opportunities. These tools can help the citizen data scientist to prototype and hypothesize so that they can test theories without making a business misstep. As the citizen data scientist environment evolves, the enterprise will see the emergence of power users and data popularity. And these will provide roadmaps to tell the organization what types of data users find the most useful and how they wish to see and use that data. Finally, and perhaps most importantly, the organization will achieve a competitive advantage by identifying trends, patterns and changes in customer buying behavior, achieving issue resolution, and identifying new markets, resource requirements, and opportunities for partnerships, new locations, and other promising initiatives. Now, let's take a look at the benefits your business will enjoy from the perspective of a data scientist. If you employ the services of data scientists or professional analysts, those team members are likely to be overwhelmed with requests on a daily basis. Many of these requests may be operational or tactical, and some may be strategic, but all will require time and attention. Because of this overload and the breadth and nature of these projects, the skills and time of a data scientist are rarely optimized. By implementing a citizen data scientist initiative, the enterprise can better utilize the resources of its data scientist team, reduce the day-to-day requests, and allow the data science team to focus on mature modeling goals and strategic projects that require 100% accuracy and a detailed, in-depth use of technology, skills, and data science techniques. Take a moment to review the content of this slide. This graphic reveals the balance of data quality produced by a data scientist and the data agility enjoyed by citizen data scientists. As you see, the role of the data scientist becomes more refined, and the citizen data scientist has the tools and the technology to use data to make good business decisions and to gain insight into business problems, make predictions, and forecast, all without the assistance of IT or a data scientist. So the time, skill, and attention of both the data scientist and citizen data scientist is optimized. In this balanced environment, the citizen data scientist can use his or her domain and business knowledge to prototype, test, theorize, and hypothesize on their own without any help. This approach will help them make decisions, and they can look to data scientists for assistance to optimize and fine-tune analytical models for more accuracy and precision. This balanced approach allows both data scientists and citizen data scientists to use and develop their targeted skills and to contribute to the process and support each other for better collaboration and a more meaningful outcome for the organization. Among the many benefits of the citizen data scientist approach is the very real benefit a business achieves by getting ahead of the curve in the market and with competitive strategy. Here, we consider the strategic assumptions related to the growth and effects of the citizen data scientist approach in the current and future market. These assumptions were developed and presented by Gartner, the well-renowned global technology analyst and research organization. As you can see, Gartner predicts that those organizations that engage in citizen data scientist initiatives will outperform businesses that do not take this approach, and they will be more competitive and better prepared by increasing productivity, optimizing resources, and making better decisions. Finally, let's examine an overview of the benefits of the Citizen Data Scientist Initiative for the organization and explore the many advantages your enterprise can achieve. By creating a culture where data democratization is encouraged and team members have the tools they need to perform data analytics, the enterprise can improve problem solving, identify all manner of business opportunities, improve data literacy throughout the organization, increase productivity and collaboration for IT, data scientists, and business users, reduce missteps and rework, improve time to market and competitive advantage, and bridge critical skill gaps for data science projects and focus. In this next section, we will dive a bit deeper into the roles of the data scientist and the citizen data scientist to better understand how the roles differ and where they can come together to provide more collaborative opportunities and improve productivity, focus, and outcomes for the organization. This graphic illustrates how the introduction of the citizen data scientist concept and supporting augmented analytics tools can advance the interests of the enterprise. When citizen data scientists assume responsibility for day-to-day analytics, data scientists are free to focus on strategic initiatives and the business can optimize their time and value. Data scientists can focus on projects where 100% accuracy is required, without the distraction of daily requests for reports, data preparation, and analytics. For the business user, the role of citizen data scientist allows access to augmented analytics tools that are easy to use and intuitive enough to use for day-to-day analysis to inform and improve individual, team, business unit, and division decision-making. Citizen data scientists can take on the role of developing and exploring hypotheses and prototypes and establish use cases to improve domain knowledge. As part of this new Citizen Data Scientist initiative, business users will be expected to share data and to use simple reporting tools to format and present that data to provide insight and consistent use of data across the enterprise. Perhaps the most important point to be made here is that if the business is to be successful in this transition, it must address the culture of the organization and promote the idea of citizen data scientists. It must establish and manage guidelines that clearly address who does what, so data scientists, IT, and business users clearly understand when and how to involve other roles in analytical refinement, data sharing, and using data to make decisions. These guidelines must also engage the IT staff to build and maintain a taxonomy and methods of tagging and identifying data for source and other information that will help analytical system users to understand how reliable and useful the information may be. In order to understand the rationale for the citizen data scientist approach, it is helpful to consider the current state of analytics within the average business environment. In the average enterprise, all or nearly all data analysis is done by data scientists, business analysts, and IT staff. In order to apply data governance controls and secure data, many businesses restrict access to reporting tools and the data that informs them, and assign prediction, forecasting, and analytics to experts, so business users can't meaningfully explore and accomplish problem solving or identify business opportunities. As you can see, this approach to data analytics is a restrictive environment that results in lost opportunities for team member development and for the organizational results the business may want. It also means that business users will continue to make important business decisions based on guesswork, opinion, and gut feelings, simply because there is no detailed, clear data available to them. The business and its team members will lose precious time as data scientists interview business users and obtain the information they will need to dive into analytics and produce appropriate reports. And because data scientists are overloaded with all types of requests, the organization will experience delays, and all parties will remain frustrated by these delays and by misunderstood requirements, aging data delivery, and other issues created by this approach to data analytics. Now that we have further defined the roles of the data scientist and the citizen data scientist and the rationale for this approach in the enterprise, it is time to step into the shoes of a citizen data scientist and see how the process of business user analytics will work for you. As with any business issue, the process starts with a clear identification of a problem or a question. Once that question or problem is defined, the citizen data scientist will use the augmented analytics tools provided for them to find and prepare data that is integrated from all data sources into a single view dashboard. The analysis of this data will provide insight into patterns and trends and the root cause of problems via smart data visualization, with system guidance to help users decide what type of visualization will be best for their data. The tools provided for assisted predictive modeling will lead the user with auto-suggestions to help them decide what analytical technique or techniques they should use for accuracy and to clearly analyze their data and make predictions and forecasts. Users can hypothesize and test theories before making a final decision on a suggested business direction. And finally, the citizen data scientist can apply these models and share this data with other users to cascade information and insight throughout the organization. It is important to note that the citizen data scientist is supported at every step by tools that will help them leverage sophisticated analytical techniques and algorithms without the skills and knowledge of a data scientist. Before we leave this section, let's look at the resulting balance of data science and business user transformation to the citizen data scientist role. When the organization shifts and establishes a new culture of data democratization and supports the evolving role of citizen data scientists, the balance of data analytics and roles and responsibilities looks like this. As we consider this new balance of roles and responsibilities, it is important to first note that the journey to a citizen data scientist environment is evolutionary and will not happen all at once. This journey requires management and organizational support and a change in workflow and processes. But the advantages to this approach are undeniable and include the democratization of advanced analytics knowledge and access to critical data for decision support, as well as an improved time to market, improved productivity for IT, data scientists, and business users, a true reduction in rework, missteps, and uninformed decisions, and a foundation for measurable problem solving and optimized opportunities. The organization will also enable a bridge of critical skills and collaboration that will enhance and improve the understanding of data, analytical techniques, and their importance across the enterprise, and it will improve business user insight into the big picture and the small details, thereby transforming team members and business users into citizen data scientists. This is an environment your business can and should want to create and sustain. This course includes detailed information and a review of techniques used in predictive analytics and in other analytical methods. Before we begin the review of these algorithms and techniques in detail, let's look at the basic definition of predictive analytics. Predictive analytics is an arena of analytics that involves forecasting and prediction of business results for planning purposes to ensure that the business has the right resources, training, budgeting, and processes to meet obligations, sustain results, and anticipate changes in customer buying needs, as well as the need for new products, locations, and other factors. Predictive analytics employs numerous analytical and modeling techniques that leverage historical data and data coming from inside and outside the organization in order to spot trends and patterns and plan for organizational needs. These analytical techniques help the business to identify relationships that may affect success and leverage opportunities as well as mitigate risk. In short, predictive analytics is crucial to the success of any company as it allows management and users to plan for future success and avoid business missteps. If we are to understand the full context of predictive analytics and the systems and solutions that support the citizen data scientist in performing advanced analytics, we also need to consider the crucial underpinning of these sophisticated yet simplified tools. The features and function of the augmented analytics solution used by citizen data scientists include the capabilities of machine learning. Machine learning techniques allow the user to focus on the questions they need to answer rather than the old, complex, confusing, and frustrating process traditionally used to derive answers from a system. Machine learning enables the software solution to learn and adapt and present and respond to information in a way that will be intuitive for human learning and understanding. There are two types of machine learning techniques that might be applied in an advanced analytics solution. The first is supervised learning, wherein the models are created using an input set of records with output data that is labeled. Regression and classification techniques are examples of supervised learning. For example, if you want to identify customers who are likely to default on loans, you need to train or instruct your classification model with labeled data. Then you can use this model to determine the likelihood of default of future borrowers. The second type of machine learning is unsupervised learning, where patterns and structures are found and illuminated within the data and then labeled. Clustering would be an unsupervised learning technique. For example, if you want to create clusters of your customers based on recency of purchase, frequency of purchase, or value of your purchase, you can use clustering algorithms to identify clusters based on the available data. We will review the different supervised and unsupervised algorithms and techniques in an upcoming section of this course. Now, it is time to dive into the details. As a citizen data scientist candidate, you may find it daunting to consider the use of analytical techniques and algorithms, but there's no reason to worry, because the augmented analytics solution you will be using is designed to recommend and apply appropriate techniques and to perform the analysis required so that you can review accurate, clear results and use those results to make decisions. While it is not necessary for citizen data scientists to become expert in each of the analytical techniques listed here, the personal and organizational transformation from business user to citizen data scientist will require a basic understanding of these techniques. That understanding will come with time, but for now, this introductory brief should help you grasp the essentials and the fundamentals of these techniques. The techniques you see listed here are those we will review in more detail. By the end of this course, you will have a better understanding of each of these algorithms and techniques and how and when they can be applied to gain insight into your data. One important note to keep in mind as we review these techniques: further information and detail on each of them can be found in the online background and support documentation for this course. The first technique we will review is used to identify trends and patterns. As you can see from the graphics presented here, trends and patterns might be applied in one of several ways. A seasonal pattern analysis will help you to identify fluctuations over a fixed period, not to exceed 1 year, so that you may identify seasonal trends and plan business accordingly. One can identify a seasonality pattern when fluctuations repeat over fixed periods of time and are therefore predictable, and where those patterns do not extend beyond a 1-year period. Seasonality may be caused by factors like weather, vacation, and holidays. It usually consists of periodic, repetitive, and generally regular and predictable patterns. Seasonality can repeat on a weekly, monthly, or quarterly basis. Cyclical patterns highlight fluctuations that do not repeat over fixed periods and are therefore unpredictable. These fluctuations may extend well beyond a year. A typical business cycle consists of a period of prosperity followed by periods of recession or depression and then recovery with no fixed duration of a cycle. During a recession, employment, product, and other factors are below the long-term trend lines. In good economic times, people have more disposable income and are willing to take vacations and spend money. The last example of trends and patterns applies to random analysis, which identifies fluctuations that are short in duration, erratic in nature, and follow no regular pattern of occurrence. Trend and pattern analysis might be used in industries like retail or travel for seasonality or weather forecasting, crime forecasts, or any one of a number of other applications. Now, let's take a look at the concept and technique of sampling and the two types of sampling used in analytics. One would use a sampling technique when working with large data sets. Simple random sampling is based on chance, and every item in the analytical data set has an equal chance of selection. A lottery system might be an example of an area of focus for simple random sampling. Another example of this type of sampling might be applied if we wanted to find the average value of all cars in the United States. Random sampling is less time-consuming and economical in nature, but there is a higher chance of bias, and it is often difficult to get a good representative sample. Stratified sampling considers a population of data divided into subgroups, with similar attributes and characteristics, defined as strata. A random selection of samples from each of these subgroups is taken in proportion to the size and defined scope of the subgroup to identify a stratified random sample. Stratified sampling is also economical in nature and is not time-consuming, but there is less chance of bias than in random sampling, and higher accuracy. For stratified sampling, you can define categorical variables for subgroups like age, gender, education, income, and others. Businesses might use sampling to identify a test group for research, for product testing, for media or political targeting, or for other purposes. Simple random sampling is economical in nature and less time-consuming than other techniques, but there is a chance of bias, and it is difficult to get a representative sample. Stratified random sampling is also economical and less time-consuming, and there is less chance of bias and higher accuracy than in simple random sampling. You will need to define the categorical variable by which subgroups should be created. For instance, the age group, gender, occupation, income group, education, religion, region, or other variables. The analytical technique that identifies and analyzes outliers is designed to isolate and illustrate these data points or items in your data set that are outside the central parameters of the data set. An outlier is an element of a data set that distinctly stands out from the rest of the data. In other words, outliers are those data points that lie outside the overall pattern of distribution. Univariate outliers are identified when analyzing a distribution of values in a single feature space, while multivariate outliers are identified in datasets with multiple feature states. When considering the cause of the existence of outliers, the reasons might be data entry errors, data processing errors, sampling errors, or any one of several other factors, including the natural cause, which does not emanate from an error but rather is truly a unique point in the data. Once you have detected outliers, you can gain further insight to determine whether the outlier data points represent items that are so far outside the norm that they need not be considered, or whether they illustrate a very unique and singular category or variable that is worth exploring, either to capitalize on a niche or find an area where an organization can offer a unique focus. When considering the use of outlier analysis, a business should first think about why they want to find the outliers and what they will do with that data. That focus will help the business to select the right method of analysis, graphing or plotting, to reveal the results they need to see and understand. And it will also help the business decide whether it should remove outliers or include them in its analytical methodology. It is important to recognize that when the outlier analysis is applied to certain data sets, the results will indicate that outliers should be discounted, while in other cases, the outlier results will indicate that the organization should focus solely on those outliers. For example, if an outlier indicates a risk or a mistake, that outlier should be identified and the risk or mistake should be addressed. If an outlier indicates an exceptional result, such as a person that recovered from a particular disease in spite of the fact that most other patients did not survive, the organization will want to perform further analysis on the outlier result to identify the unique aspects that may be responsible for the patient's recovery. When a business uses outlier analysis, it is important to test the results and analyze the overall data set and environment to be sure that the presence of outliers does not indicate that the data set may be more complex than anticipated and may require a different form of analysis. You might think that a few dangling outliers in your data would be unimportant. After all, those outliers do not reflect the mainstream data. But detecting outliers is of crucial importance to businesses and organizations that focus on research, physics, finance, economics, and technology considerations, and cybersecurity and machine learning. The outliers technique is the final technique we will discuss in this section. In the next section, we will continue our review of algorithms and analytical techniques, beginning with forecasting. In this section, we will cover additional analytical techniques. The previous section of this course addressed trends and patterns, sampling, and outliers. In this section, we will discuss forecasting and classification techniques listed on this slide. And as before, we will provide examples of how and when to use these techniques. Remember, there is more information and detail on each of these techniques in the online background and supporting documentation for this course. We all understand the importance of planning and forecasting. Forecasting techniques allow the business to more accurately plan for everything from additional resources to expanded locations, new products, changes in customer buying behavior, stock and inventory needs, and supplier network expansion. Forecasting considers historical data and values to analyze variables and results for the future. These forecasting techniques include Holt-Winter's exponential smoothing, which is a time series forecasting method. Time series forecasting methods are used to extract and analyze data and statistics and characterize results to more accurately predict the future based on historical data. The Holt-Winters forecasting algorithm allows users to smooth a time series and use that data to forecast areas of interest. Exponential smoothing assigns exponentially decreasing weights and values against historical data to decrease the value of the weight for the older data. In other words, more recent historical data is assigned more weight in forecasting than older results. This technique might be useful in forecasting the number of viewers by day for a particular game show for the next 2 months, or if an insurance claims manager wants to forecast policy sales for next month based on the past 12 months of data, and in an instance where a power generator company wants to predict the electricity demand for the next 2 months based on the past 2 years of daily power consumption data. Holt-Winters should be used only when the data series is stationary. Single exponential smoothing is used for forecasting data with specific levels, and in real-life data this is hardly ever the case. And finally, Holt-Winters is only used for univariate data forecasts. ARIMA, or Autoregressive Integrated Moving Average, predicts future values of a time series using a linear combination of its past values and a series of errors. In this example, we see an analysis by month for the sales volume of a company with the actual versus forecast amounts. The ARIMA model is suggested for short-term forecasting. It is only for univariate data forecasts, but it is important to note that there might be other things affecting the output and dependent variables. Because ARIMA doesn't take into account the influence of other predictors while forecasting, forecasts might not be accurate. This type of forecasting would be useful when a pharmaceutical company wants to predict the sales of a drug for the next 2 months based on drug sale data from the past 12 months. ARIMAX, or Autoregressive Integrated Moving Average, with explanatory variable model, can be viewed as a multiple regression model with one or more autoregressive terms and/or one or more moving average terms. The ARIMAX forecasting method is suitable for forecasting when the enterprise wishes to forecast data that is stationary, non-stationary, and multivariate with any type of data pattern, like level, trend, seasonality, or cycle. An example of an instance where one might use the ARIMA technique would be in looking at the GDP of India, or if a company wants to forecast its product line growth for the next couple of years based on data from the past 30 years. In that case, the predictor variables would be yearly consumer inflation rate, yearly GDP data, and yearly population growth rate. When using this analytical technique, there is an assumption of a linear relationship between the predictors, x, and the target variable, y. i.e., the scatter plot of each predictor versus target variable should be nearly as shown in figures 1 and 2 in this graphic. Further limitations include the assumption that there is no multicollinearity in the data. Multicollinearity generally occurs when there are high correlations between 2 or more predictor variables. Examples of correlated predictor variables, also called multicollinear predictors, are a person's height and weight, age and sales price of a car, or years of education and annual income. Now, let's take a look at analytical techniques for classification. The concept of classification helps one to organize data into subgroups based on assigned categories or classes. As we review the various techniques, you will notice that several types of analytical techniques may be appropriate for a particular issue. Let's say, for example, to identify the probable effectiveness of medical treatment, or to identify the probability of fraud or loan default. As you gain confidence in your use of the tools and techniques, you might decide to perform your analysis on a particular data set using more than one technique in order to gain further insight into the data. Included in these techniques is logistical regression, which measures the relationship between the categorical target variable and one or more independent variables. Binary logistic regression classification makes use of one or more predictor variables that may be either continuous or categorical to predict the target variable classes. Multinomial logistical regression is helpful in identifying important factors that will impact the target variable and the nature of relationships between each of these factors and dependent variables. Let's consider an example. What if a bank loan officer wants to predict if loan applicants will default or will not default based on attributes such as loan amount, monthly installments, employment tenure, how many times the applicant has been delinquent, annual income, debt-to-income ratio, and other factors? Here, the target variable would be past default status, and predicted class would include values yes or no, representing likely to default or unlikely to default classes, respectively. Binary logistic regression classification is applicable only when the target variable is categorical, and the sample size must be at least 1,000 in order to get reliable predictions. Binary logistic regression is not suitable when number of classes is greater than 2. The next type of classification technique we will review is the decision tree. Classification trees are used when the target variable is categorical, and as the name implies, are used to classify and divide the data into these predefined categories of a target variable. Regression decision trees are used when the target variable is numeric. A business might use a classification decision tree to analyze the likely quality of wine based on the level of free sulfur dioxide. Or a business might analyze past behavior of customers on a retail website and look at variables like the number of days from the last purchase, the brand preference, income, age, gender, website visits, location, and the total amount of purchases. If we want to predict wine quality on a scale of 3 to 10 based on alcohol level, free sulfur dioxide, volatility, and other issues, we would use the regression decision tree model. Similarly, regression trees can also be used to identify the market segment, identifying who is more likely to respond to a future mailing. There are limitations to the decision tree classification and regression techniques. For example, frequent changes to the data will lead to substantial differences in the output, so decision trees should not be applied on data that fluctuates significantly. There must be predefined classes for target variables in the dataset. It should also be noted that the decision trees are prone to errors and classification problems, with target variable containing many classes and training datasets that contain a relatively small number of records. The K-nearest neighbor, or KNN algorithm, analyzes all available data points and classifies this data, then classifies new cases based on these established categories. It is useful for recognizing patterns and for estimating. KNN might be used to determine the quality of paper based on acid durability, or it might be used by a credit card company to determine which potential clients would qualify for a credit card and at what interest rate, as well as what their credit limit might be. Another situation in which one might use KNN would be if a scientist wants to predict the likelihood of a successful, repeatable outcome for a pharmaceutical compound based on previous use of a particular ingredient. Let's consider the limitations of the k-nearest neighbor technique. First, the data needs to be scaled before it is input in the algorithm, or it might lead to a high percentage of misclassification and, in turn, low accuracy. The KNN method is not suitable for classifying categorical variables, and individual variable importance cannot be measured, as in which variable or variables are most important or have the highest contribution in the classification model. The naive Bayes technique is suitable for binary and multi-class classification. It is a supervised classification technique used to classify future objects by assigning class labels to instances and records using conditional probability. In supervised classification, training data are already labeled with a class. For example, if fraudulent transactions are already flagged in transactional data, and if we want to classify future transactions into fraudulent versus non-fraudulent, then that type of classification would be called supervised. Let's say we want to classify fruit. Fruit may be considered to be an apple if it is red, round, and about 3 inches in diameter. If we have data on 1,000 pieces of fruit, including features or characteristics of each one, we can classify the 1,000 pieces of fruit, characteristics such as shape, length, color, sweet, sour, etc. A business might also use naive Bayes for weather forecasting, where the analysis is based on temperature, humidity, pressure, and others. And it can predict if it will be rainy, sunny, or windy tomorrow. There are several limitations to the naive Bayes classifier. First, this technique assumes that every feature predictor is independent, which isn't always the case. Secondly, the training dataset should be adequate enough to represent the entire population, containing every combination of class label and attribute. If you don't have the occurrence of a class label and a certain attribute value together in the training dataset, then the frequency-based probability estimate will be 0 for that combination in future data. This problem happens when we draw a training sample from a population and the drawn sample is not fully representative of the population. Naive Bayes does perform well in case of categorical input variables compared to numerical variables. For numerical variables, normal distribution is assumed, which is a strong assumption. The last technique we will consider in the classification category is the support vector machine, or SVM. This is a supervised learning model that analyzes data used for classification and regression analysis. Using a set of training examples, each data point is marked as belonging to one or two categories, and an SVM training algorithm builds a model that assigns new examples to one of the categories. A business might use this technique for credit or loan approval analysis, looking at a set of transactional attributes to predict whether a client will default on a loan. A hospital or physician might use it for medical diagnosis, looking at symptoms to predict if a patient has a particular disease. Limitations for the support vector machine technique include the fact that the processing time of the SVM algorithm can be high for large datasets, and the fact that the technique is less effective on datasets with overlapping classes. This brings us to the end of this section review of analytical techniques. This review will be concluded in the next section of this course. In this section, we will cover the remainder of the analytical techniques, including clustering, correlation, regression, frequent pattern mining, hypothesis testing, and descriptive statistics. Remember that there is more information and detail on each of these techniques in the online background and supporting documentation for this course. Clustering is another crucial analytical technique that splits data into groups when pre-assigned categories or classes are not available. It is important to note that there are numerous types of clustering techniques. In this section, we will examine 2 of those techniques in depth in order to give you a better idea of how these techniques can be used. The k-means clustering algorithm is a process by which objects are classified into a number of groups so that they are as much dissimilar as possible from one group to another and as similar as possible within each group. K-means clustering is a grouping of similar things or data. Let's say a business wants to organize customers into groups or segments based on similar traits, product preferences, and expectations. Segments are constructed on the basis of the customer demographic characteristics, psychographics, past behavior, and product use behaviors. Let's look at another example of clustering. A business might wish to conduct a discount analysis and customer retention study in order to help the organization target discounts to specific customers and visualize segments of sales groups based on discount behavior as well as customer churn to identify segments of customers on the verge of leaving. Limitations for use of the K-means clustering algorithm include the fact that the number of clusters must be determined beforehand. You should also note that this technique does not yield the same result with each run, since the resulting clusters depend on the initial random assignments for group centers. If the data is input in a different order, it may produce a different cluster if there are too few data points. So you'll want to have a large enough data set. Keep in mind that K-means is suitable only for numeric data and that variable standardization is necessary if you wish to achieve the right outcome, and that empty clusters can be obtained if no points are allocated to a cluster during the assignment step. Hierarchical clustering is a process by which objects are classified into a number of groups so that they are as much dissimilar as possible from one group to another and as similar as possible within each group. This technique might be used to analyze movie ticket booking for website users. Data can be grouped into movie freaks, moderate watchers, rare watchers, based on their past movie ticket purchasing behavior, such as the number of days from the last movie seen, the average number of tickets booked each time, the frequency of ticket bookings per month, and other factors. Keep in mind that this technique is relatively time-consuming as compared to other clustering methods, and based on the distance calculation method chosen, this algorithm may sometimes get influenced by outliers. Also, the distance measure used to separate the data points in a cluster is affected by the scale of variables, so scaling normalization of variables is necessary prior to clustering. Another analytical technique that is crucial to business analytics is correlation. In this category, we will look at two correlation techniques. The first is the Pearson correlation. The Carl-Pearson correlation measures the degree of linear relationship between two variables. Like other forms of correlation analysis, the Carl-Pearson method measures the strength of relationships between only two variables, without taking into consideration the fact that both these variables may be influenced by a third variable. Here is an example of where it might be appropriate to use the Pearson correlation. Let's say a bank wants to find the correlation between income and the credit card delinquency rate of credit card holders. This graphic depicts the results of that assessment. The limitations of the Carl-Pearson method include the fact that correlation is affected by outliers, and that the correlation method measures the strength of relationship between only two variables, without taking into consideration the fact that both these variables may be influenced by a third variable. The Carl-Pearson technique can handle only numeric data, and in the case of categorically ranked variables, these need to be converted into numeric ranks in order to use the Pearson correlation method. Now let's look at the Spearman rank correlation. The Spearman's rank correlation is a measure of correlation between two ranked or ordered variables. This method measures the strength and direction of association between two sets of data when ranked by each of their quantities. This analytical technique might be used when an educational organization wants to assess student ratings based on two different sources of observation, or when a market research agency wants to cluster various survey responders into groups based on the rank correlation output. The limitations of the Spearman method include the fact that this correlation method measures the strength of the relationship between only two variables without taking into consideration the fact that both these variables may be influenced by a third variable. The Spearman technique can handle only numeric data, and in the case of categorically ranked variables, these need to be converted into numeric ranks in order to complete the analytical technique. In the category of regression analytics, we will look at two techniques. Regression analysis predicts change in one variable based on change in one or more variables. The first regression technique is simple linear regression, a statistical technique that attempts to explore the relationship between one independent variable, x, and one dependent variable, y. This method helps a business identify the relationship between x and y and the nature and direction of that relationship. A business might use simple linear regression when it wants to measure the impact of temperature on yield in order to better predict the availability of product and how the yield will affect inventory and sales. Simple linear regression is limited to predicting numeric output. The dependent variable has to be numeric in nature, and in a simple linear regression, the minimum sample size should be 58. This technique handles only two variables, one predictor and one dependent variable. But usually there are more than one predictor correlated with the dependent variable, which can't be analyzed through simple linear regression. The second technique is multiple linear regression. Multiple linear regression is a statistical technique that is designed to explore the relationship between two or more variables, x and y. It is useful in identifying important factors, x, that will impact a dependent variable, y, and the nature of the relationship between each of the factors and the dependent variable. Linear regression is limited to predicting numeric output, so the dependent variable has to be numeric in nature. This technique might be used by an agriculture production firm to predict the impact of the amount of rainfall, humidity, and temperature on the yield of a particular crop. Or perhaps a retail company might want to measure the impact of product promotions and holiday seasonality on product sales. The multiple linear regression technique is limited to predicting numeric output, and a dependent variable has to be numeric in nature. The minimum sample size should be at least 20 cases per independent variable. Multicollinearity is a situation when two or more independent variables are highly correlated with one another, and these should be removed before running the model. In this graphic, we see an example of frequent pattern mining. Frequent pattern mining, also known as association rule mining, is an analytical process that finds frequent patterns, associations, or causal structures from data sets found in various kinds of databases, such as relational databases, transactional databases, and other data repositories. Given a set of transactions, this process aims to find the rules that enable us to predict the occurrence of a specific item based on the occurrence of other items in the transaction. Frequent pattern mining could be used if a retail store manager wanted to conduct market basket analysis to come up with a better strategy of product placement and product bundling. Another example of possible application of frequent pattern mining would be when a bank marketing manager wishes to analyze which products are frequently and sequentially bought together. Each customer is represented as a transaction containing the ordered set of products. This analysis would allow the user to predict which products are likely to be purchased simultaneously and sequentially. Limitations for the frequent pattern mining technique include the fact that processing time for running this algorithm is relatively high when compared to other algorithms due to the millions of transaction-level data in the input. The user must also possess a certain amount of expertise in order to find the right settings for support and confidence to obtain the best association rules. Now let's look at hypothesis testing. Hypothesis testing answers many questions, examples of which are illustrated on this graphic. It will help you determine whether two samples are different, whether medical treatments are effective, whether two dimensions under consideration are related or independent, and many other refined determinations. Hypothesis testing techniques include the chi-square test of independence, used to determine whether there is a statistically significant association between the two categorical variables. This technique is used to determine if the relationship exists between any two business parameters that are of categorical data type. An enterprise might use chi-square to determine if there is a relationship between the region in which a product is purchased and the product or category of product that is purchased. One might use this technique to determine whether gender is related to a voting preference, or whether the two data points are independent and unrelated. The chi-square test of independence can be applied on only two categorical variables, in other words, for two dimensions, and the number of data points should be at least 50. The frequency count for each dimension value combination, or each cell value of the contingency table, should be at least 5. Keep in mind that this technique displays the presence or absence of an association between two parameters, but it does not measure the strength of association, as the correlation technique would. The one-way ANOVA test is used to determine whether there are any statistically significant differences between the means of 3 or more independent, unrelated groups. An ANOVA test is a way to find out if survey or experiment results are significant. It will determine whether you should reject the null hypothesis or accept the alternate hypothesis by testing groups to see if there is a difference between or among them. Let's look at the example displayed here to see how we can use one-way ANOVA test to determine if out of 3 or more rivers, at least 2 of them differ significantly from each other in terms of pH, TDS, and other factors. You might also use this technique to determine the effect of 3 different diets on a person's cholesterol levels and weight. When using the one-way ANOVA test, keep in mind that the total data points should be more than the total number of groups. Be sure to remove outliers from the data before applying this technique, as this method is sensitive to outliers and will lead to incorrect results if outliers are not removed. Now let's look at the independent sample t-test. This test is a statistical method of hypothesis testing that determines whether there is a statistically significant difference between the means of 2 independent samples. For example, as in this displayed result, we might use this technique to determine whether male employees in a particular company earn more than female employees, or one might use this method of analysis to determine whether the average value of a sedan type of car is significantly different from an SUV type of car. The independent sample t-test can be applied on only 2 samples, 1 dimension with 2 values, and 1 measure at a time. And observations within each group must be independent. The values in each group must be normally distributed, and the number of data points should equal at least 30. The last hypothesis testing technique we will review is the paired sample t-test. This technique is used to determine whether the mean of a dependent variable, e.g. weight, anxiety level, salary, reaction time, is the same in 2 related groups. For example, one might consider 2 groups of participants that are measured at 2 different time points, or 2 groups that are subjected to 2 different conditions. Or one might use this technique to compare unemployment, GDP growth, or other factors for a time period during which one president was in office versus the results in these areas during the period another president was in office. Paired t-test is used to evaluate the before and after of a situation, treatment, condition, and other factors. The paired sample t-test can be applied on only 2 samples, 1 measure and 1 time dimension or a sequence ID, to decide the cut point for division of measure values into pre- and post-samples. To use this technique, the number of data points should be at least 30. The next technique we will review is descriptive statistics. This technique helps users to describe and understand the features of a specific data set by providing short summaries and a graphic depiction of the measured data. There are numerous methods of descriptive statistics, including mean, median, and mode methods of averaging data and percentile, quartile, skewness, and standard deviation variance methods, as well as plotting methods like box plots and histograms. To better understand these methods, let's take a moment to review each one. Mean is the average of all the data values. This measurement can be biased in a case where there are a significant number of outliers present in the data. Median is the value in the middle when the data items are arranged in ascending order. The measure is relatively robust where there are a significant number of outliers present in data. Mode is the most frequently occurring value in a series of data. If there is no repeating value in the data, there would be no mode. And percentile represents a percentage position in a list of data. For example, the 20th percentile is the value below which 20% of the observations may be found. Descriptive statistics can be used to reveal the deviation of stock prices over a one-day period, to find out the average age and income for a particular type of product category purchased, or to identify the most popular dish served in the restaurant, or find out the most frequent rating given by customers for a given movie or restaurant, or the most frequent size or category of a sold product. Use descriptive statistics when you need to understand what is going on in your company at an aggregate level, and when you want to summarize and describe different aspects of your business. There are no specific limitations for this type of analytical method. This concludes our review of the various algorithms and analytical techniques you may use in your role as a citizen data scientist. Remember that you do not have to be an expert in these techniques because your augmented analytics solution will provide the foundation, guidance, and recommendations to help you work through your analysis. But as with any other tool, topic, or area of focus, you're bound to get more out of the exercise if you have a basic understanding of the techniques and if you familiarize yourself with the names, uses, and approaches to analytics. Once again, remember that additional detail and information for all of the techniques we have discussed is included in the supporting documents for this course. Now that we've completed our review of the analytical techniques and algorithms you will use as a citizen data scientist, it's important to provide some context and examples that will further your understanding of how to apply these techniques to the issues you face during your average business day. In this section, we will look at specific use cases to illustrate how augmented analytics can provide you with the foundation for decision-making by revealing results, the root cause of problems, trends and patterns, and opportunities you can leverage to improve time to market, identify and mitigate risk, and accomplish many other tasks. For each of these use cases, we will provide suggestions for the type of analytical techniques one might use. Keep in mind that every type of business use case can be analyzed using more than one technique. And while we will not provide an exhaustive list of recommendations for each of the examples we cover, we will give you a place to start. The use cases listed on this graphic may or may not apply to your business needs, but they will no doubt provide inspiration to create your own use cases. Our first use case is one that considers customer churn. Customer churn is something every business faces, and the cost of attracting, acquiring, and retaining clients is significant for every business. So customer churn is something you definitely want to avoid. This analysis takes into consideration your customer base, demographic information, and the way your customers use products or services. By understanding why customers abandon your business, you can address the root causes and issues that create customer churn and prioritize these issues to address the most important factors first. You can alter marketing messages and campaigns to improve results and even create new products or services that will improve customer satisfaction and retention. Among the many considerations you might analyze for customer churn, your business use case might include services that each customer uses, like phones, the number of phone lines, internet services, online security, online backup, device protection, tech support, and streaming TV and movies. Or you might look at customer account information, such as how long they have been a customer, the contract length and detail, payment method, paperless billing, monthly charges, and total charges. Customer churn analysis might also include demographic information about customers like gender, age range, and if they have partners and/or dependents. When considering customer churn analysis, one might use the binary logistic regression technique. In this use case, we will look at fraud mitigation, a topic that is near and dear to bankers, credit card businesses, mortgage companies, and financial investment firms, among others. While one may think of fraud most commonly associated with finance and banking, or IT functions or networks, industries like healthcare, government, and public sector are also at risk. And fraud can take many forms and affect the supply chain in numerous ways. In order to protect the business from fraud, the team must anticipate the type of customer or typical situation in which a customer or transaction might be identified as fraudulent. An enterprise can leverage predictive analytics to identify the most likely areas and actors that will be involved in fraudulent activities. And by developing fraud detection models, the enterprise can reduce the cost and the negative impact to the business reputation and the bottom line. Businesses that are proactive in identifying these risks can better optimize resources and respond to changing trends and patterns. Augmented analytics is a perfect way to accomplish that task. By looking at historical data and identifying the signs of fraud, the business can create processes, set thresholds and alerts, and monitor results to establish a comprehensive fraud detection and mitigation model that will reduce risk and cost and avoid a negative impact on the bottom line. For this type of business use case, you might use a classification technique like K nearest neighbor. When analytics are applied to maintenance management activities, the business can reduce downtime, anticipate when and how equipment will need to be maintained, and what resources and parts they will need to accomplish the maintenance tasks, so the enterprise will not be caught unaware. The enterprise can plan to order parts and schedule downtime for equipment. For a business that places and maintains equipment in a customer location, this type of planning is just as crucial. The enterprise does not want to risk its reputation with unanticipated downtime or the loss of revenue. Business use cases for this type of analysis might include manufacturing and production environments, utility and infrastructure businesses, and service industries. Forecasting necessary maintenance and equipment replacement and ensuring that the business is ready with resources and funding is critical and will help the business to optimize parts and inventory management, schedules and training, costs, customer satisfaction, and revenue. This type of analysis allows the business to take the guesswork out of maintenance and schedule maintenance tasks appropriately. In so doing, the enterprise can optimize resources, parts, inventory, and schedules to improve customer satisfaction and to manage costs. For a use case of this nature, you might want to use a forecasting technique like Holt-Winters. Quality is an issue for every business. Maintaining the integrity of a product or service is a paramount concern and will ensure customer retention and protect the company's reputation. Businesses that do not focus on quality will lose customers and market share and may experience legal risk or liability. In order to ensure quality outcomes, the business must identify quality issues to streamline processes and address product design imperatives or other flaws or problems. The benefits to quality control are numerous and include protecting your brand reputation, reducing business liability and risk, improving market positioning and reputation, and increasing and sustaining customer satisfaction. Using advanced analytics to identify quality issues will improve production processes, protect the business against liability claims, and allow the organization to more easily upgrade products, create new products and services, and anticipate issues along the way. Advanced analytics and predictive analysis can be used to achieve these goals in an IT consulting business, in telecommunications, in manufacturing, and many other industries. One might use a trend and pattern analysis for this type of business use case. This use case considers the subject of demand planning. Demand planning allows the business to anticipate demand during a high demand selling season, or in a particular area of the country, or for a particular product or service. By forecasting demand, the business can plan for the number of suppliers, plan production schedules and resources for production, and ensure that inventory will meet demand. With augmented analytics, the business can accurately forecast the need for new warehouse facilities, new suppliers, new locations, new sales resources, and other needs, and also forecast demand for products and services across market segments. Businesses will benefit by anticipating changes in buying behavior, optimizing products and inventory, identifying the need for new features and design, optimizing the supply chain and production and distribution, and better controlling inventory to improve the bottom line and improving customer satisfaction. Augmented analytics allows the business to anticipate production demands, plan for new locations and markets, and predict targeted customer buying behavior and changes in product demand across multiple market segments. Businesses invest significant funding in inventory and warehousing, shipping, and every step along the supply chain. Where demand can be optimized, the business will alleviate the issue of inventory shortages or overages and optimize production and distribution to improve the bottom line and ensure that customers are satisfied. For this type of use case, the business might use K-means clustering method of analysis. The use case for product and service cross-selling and upselling is useful to understand what your customers like and where you can cross-sell, bundle, or upsell other products by leveraging what you know about your customer buying behavior. Every business needs to know what makes a customer buy or try another product, and what features, design, or product or service combinations might help the business sell more units. For example, a retail store manager may want to analyze the optimal and strategic placement of various products in order to increase cross-sales. By looking at transactions, the date of a purchase, and what the customer purchased, the business can develop a comprehensive understanding of behavior and brand loyalty. The enterprise will benefit by increasing revenue, targeting new products and services, creating marketing messages to target a particular customer demographic, and improving brand loyalty and product and service mix. One could consider the date of purchase and the products purchased to find item combination and frequency of purchase. To perform analysis on this type of use case, the business might use frequent pattern mining. Now let's look at customer targeting. In order to anticipate your customer needs and target customer and market segments, your business must identify things that cause a specific customer to make a buying decision, so it can create products, add features, market and advertise appropriately, and reach out to customer targets with personalized messaging. To accomplish this analysis, the enterprise can look at customer demographics, the type of outreach they're currently doing and how much response they're getting, customer feedback, and other data. In this particular use case, the analysis looks at home ownership and the customer need for loans and mortgages, what type of customers will default, which market segment will respond to a particular type of marketing, and other factors. To perform this type of analysis, the business might look at demographic information, the number of days since the business last sent an email to the customer, the existing loan or account details, current home ownership status, and the customer's previous default history. By refining customer targets, the business can improve customer satisfaction and sales conversion, add additional product features, and design to satisfy customer needs. It can anticipate pricing changes, the need for new products and new sales resources, and plan for adequate marketing and advertising budgets. For this type of use case, the citizen data scientist might utilize the binary logistic regression technique. This is a use case for loan approval, where a bank is trying to determine what type of loan applicant is most likely to default on a loan, who is most likely to pay on time, and other factors. In this case, the analysis includes demographics like gender, age, education, marital status, occupation, past loan history, and other details. A bank, credit card company, financial investment firm, or venture capital business might benefit from this type of analysis by enabling productivity, anticipating and addressing the types of clientele that are most likely to default on a loan, mitigating risk, and optimizing available loan funds and investment. This business use case might be approached using the support vector machine technique of analysis. This use case focuses on human resource attrition. Like customer retention, human resource retention is important because stable retention eliminates the cost of advertising, interviewing, hiring and training for a new employee. Human resource attrition analysis allows the business to see which employees are likely to leave and which will remain loyal based on tenure, training, job responsibilities, and other factors. The analytical data set will include pay, performance and reward information, past work experience, team member demographic information like gender, age, education, marital status, and employment tenure, as well as job satisfaction rankings for things like satisfaction with pay, survey responses, and more. The business might also include performance reward contingencies. By reducing employee turnover, the business can improve hiring and screening processes, optimize existing human resources and compensation, improve training programs, and increase employee loyalty and satisfaction. For this business use case, the business might use the binary logistic regression technique. Next, let's look at a use case for online target marketing. This is a technique that's used to assess and track a website or app to determine what types of marketing campaigns will perform well for your business and help you create more targeted campaigns that will increase online sales. The analysis includes campaign-related information and messages, cost per click, and other factors. Businesses can benefit from this type of analysis by testing theories and hypotheses for price changes, new messaging, added features, thresholds for cost per click pricing, and sales conversions based on clicks. Refining this approach can improve return on investment and customer targeting and improve sales conversion, optimization of marketing budget, and brand loyalty. The business can use the K-nearest neighbor analytical technique for this type of use case. Marketing optimization allows the business to determine the influence of marketing and advertising campaigns and identify whether marketing expenses are effective for the business, so the marketing budget can be optimized and the business can improve return on investment. A business might include advertising expenses, and in the case of a hospitality business, it could include vacancy rates and other occupancy costs and optimization factors. A service-based technology business might look at its marketing channels, including ads on social media and in industry journals, to determine where its marketing budget achieves the best results and further target specific types of clients that consistently sign high-value contracts. The business will benefit by gaining a solid understanding of targets and customer segments and developing a successful marketing and advertising campaign to target each appropriate segment, thereby optimizing the budget and increasing sales conversion and competitive advantage. In its initial use case analysis, the business might use the Carl Pearson correlation technique and further refine its results by using multiple linear regression. This use case considers the analysis of external data for decision-making. A business often needs to combine internal data from its own data repositories with external data to analyze things like rainfall, population growth or changes, gross domestic product, and other data points. Government agencies, nonprofits, and organizations that manage research, health, education, and other disciplines can benefit greatly from this type of external analysis. A business might be looking at housing vacancy rates, college admission, or other issues where external data is married with internal data to gain a clearer understanding and forecast results. Businesses might look at GDP or in the case of seasonal tourism, at the historical levels of rainfall, vacancy rates in hotels, and other factors. This type of analysis benefits a business by helping it to plan for resources, locations, partners, suppliers, marketing messages, supply, pricing, the development of new products and services, all to satisfy a niche, mitigate risk, and assess liability and other considerations. To perform this kind of analysis, the business might use the multiple linear regression technique. As we conclude this section and complete the use case review, it would be beneficial for you to review the supporting course documentation, in particular the section entitled, "What do you want to do?" This section lists analytical technique categories and aligns them with the types of questions or business issues you may want to analyze. Once you have completed this review, take the time to jot down a few ideas of your own regarding business use cases that involve existing issues or questions within your organization, and consider the types of analytical techniques available to you to choose one or more that may be appropriate for your use cases. If you need to go back and review previous sections on analytical techniques or sample use cases in order to develop this information, please take the time to do so. This will put in context the business issues that you will face on a day-to-day basis as a citizen data scientist. Earlier in this course, we looked at predictive modeling and its importance to the business for accurate forecasting and planning. In this section, we will consider the benefits of assisted predictive modeling techniques and tools, and how citizen data scientists can use these tools and techniques to analyze any business issue or use case, with forecasting, regression, clustering, and other techniques. These techniques can be used by citizen data scientists without the assistance of a data scientist, analyst, or IT staff member, and they will help every team member to make fact-based decisions and clearly identify issues and gain insight into business results in a way that is meaningful to their role. In a moment, we will see these tools in action, but first, let's look at the assisted predictive modeling process you will follow from beginning to end. This graphic shows the steps in the process, and it will help you to understand how analytical workflow and processes can complement and support your daily routine. Take a moment to read through the steps in the process, from selecting the algorithm technique to fine-tuning the resulting model. Keep in mind that as you prepare data, choose a visualization technique and appropriate analytical techniques, you will be guided by auto-suggestions and recommendations to help you compile, analyze, and present your data in the best way possible without guesswork. The auto-insight approach to assisted predictive modeling simplifies the analytical process even further by working automatically on various possible algorithm techniques based on datasets and features, and then presenting the users with the most relevant, best fit algorithm and results, and with visualization and insight presented in simple language. Users simply have to choose a dataset, and the system will find and present the best possible insights from the dataset with simple interpretation and meaningful visualization. This process utilizes predictive modeling techniques to reduce the time and skills required to produce accurate, clear results quickly and dependably, and it leverages machine learning to collect and analyze data with the guided assistance of a smart solution. Auto-insight lets the citizen data scientist bypass the selection of data columns and analysis techniques such as classification or clustering. Instead, you select the dataset to be analyzed, and the system interprets the dataset, selects important columns of data, analyzes its type and variety and other parameters, and uses intelligent machine learning to automatically apply the best algorithm and analytical techniques and provide data insight. Auto-insight understands data and applies correlation, classification, regression, or forecasting, or whichever technique is relevant, based upon the data the user wishes to analyze. Results are displayed using visualization types that provide the best fit for the data, and the interpretation is presented in simple, natural language, and insights that users might otherwise miss will be automatically reflected and revealed for clear results. This seamless, intuitive process enables business users to quickly and easily select and analyze data without guesswork or advanced skills. Next, we will review the augmented analytics tools that will serve as a foundation for the citizen data scientist approach to self-serve data analytics environments. This review will provide an overview of the tools, and here you will come to better understand how your role as citizen data scientist can help you to effectively execute your responsibilities within the organization and become a true asset to the business. The Smarten Augmented Analytics Suite is comprised of a number of primary functions, including self-serve data preparation, smart data visualization, and assisted predictive modeling, or plug-and-play predictive analysis. With self-serve data prep, you can connect to various data sources and mash up data, enjoy auto-suggestions to identify relationships, joins and typecasts, and other opportunities for data transformation and cleansing. You can also explore, clean, shape, and reduce data and combine that data, and you can perform comprehensive data searching and profiling. These tools enable a clear picture of data lineage and provide tools for collaboration, IT certification of data, and new and improved workflow and data governance. Smart data visualization includes auto-suggest recommendations to help you visualize data in the best possible way based on the data type, the nature of the data volume, data patterns, and data dimensions. The assisted predictive modeling tools enable users with simple tools and processes and walk them through the process to choose a dataset, a type of algorithm technique like classification, forecasting, or clustering, and then the system automatically recommends the best fit algorithm and presents the citizen data scientist with results and visualization to interpret the data in the right way. As you can see, these tools allow the business user to prepare and analyze data without the assistance of IT staff or data scientists, and without professional knowledge of sophisticated algorithms and analytical techniques. Users with no data science background can create, share, and use predictive models in minutes. In the first example, we have created flight data, including considerations for arrival, departure, the weather, and other factors. Here, we have transformed the data using self-serve data preparation to join flight data with weather data, and we now have a data set with information on all flights, including arrival and departure delay and weather parameters for arrival and departure of each flight. Here, the user can leverage auto-suggestions to create and view the right model for the data. The objective of this model is to analyze this data set to find the possible reasons and factors that might affect flight delays. With the data set defined, we will use regression technique with targeted variable arrival delays, and we will use predictors such as departure delay, snowfall at arrival and departure, and precipitation at arrival and departure to create a regression model and analyze results. After we choose this data and the regression algorithm technique, the system will work on finding the best fit algorithm and automatically present results and insights. As you can see, it has chosen multilinear regression analysis as the best technique for this use case, and the interpretation is provided in simple language, so the user can easily understand and use the data for insight. The analysis reveals what will cause or influence arrival delays. Here, the graphic depiction of the results provides a visual display of the departure versus the impact on arrival delays, and in the next graphic, we can see the consideration for precipitation. And if the citizen data scientist wants to dig deeper or take the initial analysis to a data scientist, the data scientist can use the technical model summary to start the next level of analysis. The next few graphics reveal the various displays and visuals that a user can leverage to see the data in a different way. Again, all of this is done based on the best visualization techniques for this type, volume, and nature of data. Keep in mind that once a citizen data scientist has gathered and prepared the data and created a model for analysis, other users can apply the model. In this way, users can collaborate and share models and data to gain insight and make decisions. Here, we see that weather and other factors will affect delays in flight departure, and that when the flight is delayed by 25 minutes, the arrival will be delayed by 56 minutes because of all the other variables we have considered. As you can see, with a few simple clicks, the user was able to get to the heart of the data, and the system did the work of selecting the right algorithm and applying the right visualization techniques and generating insights in simple natural language. Now, let's go back and choose the clustering analytical technique and select our data again. This time looking at which carriers would be the best choice to ensure on-time departure and arrival. Now the system elects hierarchical clustering as the best analytical technique. The displayed smile emoji tells the user that this is a good technique to use on this type of data. And here the data is revealed in graphic form for review, where the user can click on factors to turn them off and on and see the results. If we wish, we can change the columns we selected for analysis without starting over again, so the user can change considerations and variables on the fly. If the user wishes, he or she can turn off the auto mode to do some more manual tuning of the data analysis to change the clustering and the analysis. Again, this data can be exported and shared with other users to improve collaboration and productivity. In the next model we created, you can see that we want to predict the quality of red wine using a classification technique and dive into the data to see that there are certain variable paths that will produce a lower quality red wine. If I am a grape grower and wine seller, I can determine which parameters to focus on to improve the quality of the wine. Again, the interpretation is provided in simple, natural language, so the user does not have to guess at the results. But let's say I decide to use a different algorithm, one other than that recommended by the system. Here, I want to apply the SVM algorithm instead. You see that I am given a warning to tell me that this may not be a suitable technique to analyze this data. I'm going to use it anyway. So we'll apply this model, and the system will give us the best visualization technique to reveal the data in the best way. After that analysis is finished, I can change parameters and again look at the data by removing variables and working through the results to gain insight. In the next use case analysis, we see that the system has suggested the multiple linear regression technique to look at the cost of medical bills. Factors like the body mass index, or BMI, being a smoker or non-smoker, and gender can be applied, and here we will see the results. If we isolate the variables to choose a male, smoker, BMI, and other factors, you can see the results and how much the medical bills are likely to rise because of these factors. Insurance companies might use this type of analysis to determine which clients should pay higher premiums based on lifestyle and other factors. Let's look at the list of models we've created here. You can see that the system provides simple key metrics to show you that the model is a good model for the data you are analyzing by illustrating the ranking by the number of stars. In this case, the model is a 4-star model. So for those who are sharing models or reusing models, there's always a simple way to assess techniques and models to be sure you have what you want. This ranking approach also allows IT to assess the model and approve models and better understand what techniques and models are the most popular among users. In this example, we're using binary logistic regression to look at sales won and lost. And here you can see that the results displayed are easy to understand. If I want to change the data, I can isolate it in the Northwest region and focus on a reseller and other factors to determine what our sales team members should target and what they've achieved so that we can uncover issues with closing sales and solve problems and better predict sales results. In this frequent pattern mining analysis, we can create a picture of what products will most likely be sold together. And therefore, we might plan promotions to bundle products, and we might see that sour cream and milk are most often purchased together. Again, I can change variables to see whether a particular store location might stand out as unique in product bundling or sales. As you can see, creating the models and exploring the data is easy, so citizen data scientists can work through these analytics without sophisticated skills. And they can become more data literate and proficient, and thereby provide the best resource asset to the organization and have the tools to make the best decisions. If we look again at the benefits of predictive analytics and the various facets of the tools and decision foundation, we can see that these tools provide a solid foundation in which to employ the citizen data scientist culture and environment. This concludes the review of the Augmented Analytics tools. I hope this has helped to illustrate the benefits and ease of use, and to provide assurance that the citizen data scientist journey is not a difficult path, but rather a path that will offer numerous opportunities to grow and contribute. We have reached the end of this course, and I would like to thank you for your attention and your commitment to the citizen data scientist journey. Whether you're a business manager or owner wishing to implement this approach within your enterprise, or a citizen data scientist candidate about to start on your journey, I hope you found some inspiration and information here to use as your skills, knowledge, and engagement evolve. Along the way, you as a citizen data scientist are likely to become a champion of data democratization, an enabler for data popularity and data literacy, and a liaison between the data scientist, IT, and business user community. As a power user of augmented analytics tools, the additional skills you develop will make you a greater asset to the organization and enhance your career opportunities. Remember, the citizen data scientist transformation cannot simply involve a staff meeting announcement. This approach requires culture change, engagement with IT staff to establish access, security, and taxonomy policies and procedures, and a collaborative commitment on the part of management, business users, data scientists, analysts, and every member of the team. Before we leave this session, I want to provide follow-up and contact information in case you have any questions in the future. And I would also like to remind you to review the supporting documentation for this course. It includes additional information about the citizen data scientist concept, the roles and responsibilities of both data scientists and citizen data scientists, the analytical techniques we've discussed, and the application of augmented analytical tools, smart data visualization, self-serve data preparation, and assisted predictive modeling within your own business environment. Well, we've made it to the end. One final thought as we conclude. You may have many questions about the commitment and requirements of the citizen data scientist role, and that's natural. It is important to know that these answers will come with time, as your organization and your team embrace the new environment of collaboration and productivity inherent in this concept. Be patient, and remember that your organization is taking a big step to improve accuracy, career opportunities, and competitive advantage. And those are things that every team member and every enterprise can and should applaud.